Welcome back. Here we are today for mathematics. And then you are with Mr. Nduli here, as well as my colleague, Mr. Nzama. We are going to actually take you through again for where we ended last week, Monday. Today, it's mathematics, as we know all, to come and have fun of trying to make sure that mathematics is accessible and understandable by all of us. So maybe without the waste of time, allow me to recall, because I said last time, everything that we do, we must make sure that we understand our identities. Then we spoke about the ratio identity, and we spoke about the square identity. We spoke about the compound. We spoke about also uh, the double angles. So whenever you see tan of an angle, let us remember that mathematically you don't see tan of an angle, but what do you see? You see sine of an angle divided by cos of an angle. Please recall that one. Then we went further to say we spoke about the square identity, which will be x squared plus y squared equals to r squared. Don't forget, when you come to trigonometry, this will be cos square of an angle plus sine square of an angle will be equals to 1. Last time, I think we actually proved why is it this equal to 1. Don't forget again, this can be manipulated. How it can be manipulated? It can be expressed as cos square of an angle is equal to, through additive inverse, this will change its sign. It's going to be 1 minus sine of square of that angle. Be careful, student. The angles must be the same. So hence, I can further simplify this by introducing a radical on both sides. If I introduce a radical both sides, this will be what? So cos of an angle can be expressed as what? As 1 minus sin square of an angle, vice versa. What do I mean by vice versa? I can make sine a subject of this equation. So what will we have under the radical sign? Therefore, we are going to have the square root of cos there. So it's going to be 1 minus cos square of an angle. So I'm just recalling the square identity. I want to believe that we still remember that one. So please don't forget that whenever you see cos in mathematics, you don't see cos as cos per se, but it can be expressed as the square root of plus or minus the square root of 1 minus 1, depends on the quadrant. So same thing applies to 1. Whenever I see 1, I don't see 1 as 1 in trigonometry. But what can I see? I can see the cos square of an angle plus sine square of an angle. So please be careful of that one whenever you are dealing with these identities. So I'm sorry about that. We also further actually engage on the other identities. So we spoke about the compound identities and the double identities as well. So maybe just to recall on what we said about those identities, so that whenever we are going to apply, we know what is it that we are applying. So we further said that we proved that cos of x minus y. So this one, it's a compound angle because it consists of two angles inside the parentheses. So we proved that it will be cos of x times cos of y, y being the second angle. And then because it's cos, it's going to change its sign. It will be what? To be sine of an angle times sine of the second angle, vice versa. What is it that we also need to take note here, learners? We must make sure that we remember that this one, it's one term because of multiplication. Also, this one, it's one term because of multiplication. Hence, what do I mean by that? The commutative property of this one, it doesn't matter. What do I mean by that? Sometimes we find them expressing as cos y multiplied by cos x plus sine y multiplied by sine x. Why is this true? It is because, remember, mathematically 2 times 3 is the same as 6, but 3 times 2 as well, it is 6. So the commutative property of multiplication, it is also applicable to this one. So please remember that we actually have to recall this one. Now, when it comes to sin, so sin of an angle, let us remember that it is actually given by sin minus y will be then equal to what? Sin of the first angle times cos of y. With sin, the sign remain the same. So it's going to be minus sin, sorry. Yes, it's going to be cos, okay, even though I say it doesn't matter, but let me just write it as it is on our formula sheet. So it's going to be cos of x times sin of y. So please be careful of that one. So also commutative property is applicable to this one. So here it's going to be minus or plus with cos, the sign will change to negative. So it's minus or plus with sign, the sign doesn't change. So if it's positive here, it is going to be positive here as well. So please be careful of that one. Then we went further to look at the double angles. So with the double angles, and then we said it's actually derived from the compound, given the fact that those angles in a right angled triangle, they can be equal. Then I made an example of what? Of cos. So the example of cos that we made, it was 45 plus 45. We know that 45 plus 45 is give us what? It gives us 90 degrees. So it is, yes, indeed applicable. So just to refresh our minds, we said cos of A plus B, where A is equal to B. What then does it mean? It can be expressed as cos of A plus A, or vice versa. It can be cos of B plus B, will be then equal to what? Cos of A times cos of A minus sin of A times sin of A, because the angles are the same. So this will be simplified to cos squared of A minus sin squared of A. So therefore, this will be what? Cos of A plus A will be 2A. What then does it mean? Whenever I see cos 2A, I don't see that one. But what is it that I see? I see cos squared of A minus sin squared of A. But I said what is important here is the relationship. If we look at the angle, it is doubled. But what is an angle here? It's single. So also here, it's single. Now, what is the relationship between these two? It says to move from a double to its identity, we divide the given angle by 2. So therefore, 2 divided by 2 will be 1. 2 divided by 2 will be 1. Hence, the example we also spoke to was cos of x can be also expressed as a double angle as well. So what will be cos of angle as a double angle? So this will be what? Here it's 1. To go to its identity will be cos squared of half x minus sin squared of half x, because to move from this one to this one, we have the given angle. So please recall that one. And with also the three identities that we spoke about, which will be what? 1 minus 2 sin squared of x, and the other one is 2 cos squared of x minus 1. So please remember that one. They are very important for you to engage on trig expressions, trig identities, trig equations. Also, in 2Ds and 3Ds, these are the identities that we will be using. So that's why I actually refresh our minds on to recall all the identities that we actually discussed last time. And then we also spoke to the identity of sine being a double angle. So that one is given by sin of 2A. I think I explained why we have got 2A here. It's when we're adding two angles of the same actual magnitude. So this will be what? It will be sin of A times cos of A plus, because it doesn't change the sign, plus cos of A times sin of A. So remember, student, this one, sin and cos and sin is the same thing because of a commutative property of multiplication. So the position doesn't matter. It will be then 2 cos, let me start with sine. It will be 2 sine, it will be 2 sine of A times cos of A. So therefore, whenever you see sin to A, you don't see sin to A, but you see this. I further said, this can be manipulated. How it can be manipulated? If we divide by 2 here and we divide by 2 here, what is it that we are going to have? We are going to have a half angle. So which then will be what? Sin of A times cos of A will be given as 1/2 of sin of 2A. Again, what is important here, learners, is the pattern, how the angles behave. Please be careful of that one. Now, whenever I see sin of an angle times cos of that angle, I don't see that one mathematically, but I see its identity, which is 1/2 sin to A, sin to A. So please be careful of that one. I just wanted us to recall on the identities. Then I gave the student a homework to say, can you please just do this one for me? And I want to believe that at home, you have done your work. So you have done your work. Let us see what is it that you did and able actually to mark our work. We were given that if cos of alpha equals to P, it's cos of alpha equals to P. If in this case becomes a condition to say whenever I see cos alpha, I don't see cos alpha, but what do I see? I see P because of an equality. Now, express the following expression in terms of P, which means our answer should consist P. It can be P and a value, or it can be P alone, or your answer should be actual in terms of that P that they are referring to. Now, how do I then approach that question? You look at the sum and you analyze it. Please, student, what is important here? It's your number pattern. So please look at the pattern, look at your algebra. Your algebra and pattern are very important when it comes to this one. So please, let us try by all means to integrate the content. Algebra, actually, it doesn't work in isolation. It is also incorporated in our trigonometry, Euclidean geometry. So all these number pattern. So in your mind, you have those interrelated chapters. So when we look at this one, we have got one term because of division sign. It says cos of alpha over t minus 45 degrees, all times sine of alpha over 2 minus 45 degrees. So what I can observe here, since we have got more than one angle inside the parentheses, this is compound. Also, it is actually compound on this one because we have got two actually expression of angles inside the parentheses. That is correct. What else can we deduce also from this one? We can also deduce that if we look at this one, it is cos of an angle. This one, it's an angle because inside the parentheses, times the sine of the very same angle because it's also inside the parentheses. What then does it mean? What comes into my mind, it's exactly what we just spoke about. It's exactly what we just spoke about. We said sin of 2a is equals to 2 sin a times cos a. However, if we manipulate the very same equation, dividing by 2 on both sides, so this and this will give us what? 1/2 sin of 2a will be then equal to what? Sin a times cos a. So do you see that the angle here and the angle here are the same? So since the angles are the same, we can conclude that when we see this, we don't see this, but we see its identity. So that's exactly what we see. I want to believe we are all still actually understanding student. So therefore, what then does it mean? We can express our numerator as what? As 1/2 times, since this is an expression of this, times what? Times sin of 2 times an angle. What is an angle here? It is alpha over 2 minus 45 degrees. I want to believe we are still following. So this will be divided by 2, which was given 2 in this case. I want to believe that you are still observing. So it is very important for us to actually analyze the pattern. So let us simplify this one. 1 times the numerator will be the numerator itself. So it's going to be sin of 2 into alpha over 2 minus 45 degrees, all divided by 2 times 2 will be 4. Now we have to distribute our angle there. So how we are going to distribute, you multiply each angle by 2 because 2 is a common factor if it's expressed in this fashion. So it is going to be what? It is going to be 2. 2 into this, 2 into a over 2. This, because it's 2 over 1, this will cancel this. Then we're left with 1. So it's going to be a, that is going to be less because 2 divided by 2 is 1. A divided by 1, it's a. 2 times 45 is going to be negative 90 degrees. So now we have got a simplified version, but it's so this one is alpha, not a. It is still in the form of a compound. Yes, we can express this as a compound again. However, there is no need if we actually understand the aspect of co-ratios. Why co-ratios? Because we have got what? We have got 90 degrees there. How then can I express this? This one, if we go to our Cartesian plane, it says we are moving, A is positive there, which means if A is positive, our angle, it is going in an anti-clockwise direction. So our alpha is positive there. But since this alpha is acute, it means that the angle we are referring to, it is less than 90 degrees. What then does it mean? After we moved anti-clockwise just before 90, we also then added negative 90. So what then does it mean with this negative 90? It means we are changing our direction to be clockwise 90 degrees. So if we've moved alpha to anti-clockwise direction, then we take another 90 degrees, we will fall on the fourth quadrant. Now, how is sin on the fourth quadrant? Sin on the fourth quadrant is negative. But because of 90, we are remembered of what? Of the co-ratios. Sin changed to cos, so it is going to be cos of alpha. So what is cos alpha? Whenever I see cos alpha, I don't see cos alpha, but what do I see? I see P. So therefore, this will be what? Negative P. So this will be our solution in terms of P. How else can we also interpret this? The other way to interpret it, as I indicated, that you can use your compound angles. But the other way to interpret it, it's whereby you decide from this step to take out a common factor to put it in a manner that you understand. So when you take out a common factor in this one, you are going to have what? You are going to have sin of negative as a common factor. So if we take out the common factor, you are going to have negative alpha plus 90 degrees because now you have taken out a common factor. So let us go back to that one. What is sin of negative A? So sin of negative A, because this is an acute angle in a clockwise direction, it's going to be negative sin A. So that's what we still have to remember. So with this one, it will then mean that our expression will be what? Will be negative sin of 90 minus alpha. I've just rearranged my actually angles. So with this one again, I will get what? The same thing. It's going to be negative because of 90. It becomes cos. It is going to be cos of alpha, which will be then equal to what? Which will be equals to a negative cos. So I want to believe that you understand that one. Hence, it's going to be negative P. So again, from the start, you could have used the compound. You were still going to get one and the same thing. So that's what I just wanted to actually explain in this one. So we look at this one. So it is also important, learners, that we also understand how we can derive this formula, because as you can see in 2024, they ask us to determine the compound of cos from the proof. So what is important here, we must remember the aspect of algebra to say, how can we express that positive in terms of negative, so that we will be using that one, because it says use the compound angle identity above to identify this one. So it is important to recall that this one can be expressed as cos of x minus into negative y. Why? Because negative times negative will be what? Positive. So it is also very important to recall that one. Now we can apply actually what? We can apply the compound that we have actually expressed above. So what is cos of actually x? It is going to be cos of x times cos of negative y. Remember, with cos, this sign changed to what? To positive. So therefore, it's going to be plus. It's going to be plus of what? Sin, the first angle, which will be sin of x, times the sin of the second angle will be sin of negative y. So let us simplify. Cos of x. So this one, because it's on the fourth quadrant, since it's on the fourth quadrant, cos is positive on the fourth quadrant. So it's going to be cos times cos of y. So this one will be plus. We actually write sin of x. But sin of negative y, since it's on the fourth quadrant, our sin of negative a or negative x has become negative. So it's going to be negative times negative sin of y. So therefore, when we simplify this, it's going to be cos of x times cos of y. Positive times negative, it is going to be negative sin of x times sin of y. Then we've proved the compound identity for cos of x plus y. So it is also examinable, learners. Please don't forget that one. So the other one that we have to actually simplify using the identities that we have just recalled, it says simplify the square root of cos 1 minus cos squared of 2a, all divided by cos of negative a times cos of 90 plus a completely. Given that, learners, it's a condition. Given that A as an acute angle is greater than 0 degrees but less than 90 degrees, what then does it mean? It is on the first quadrant. That's where you'll get your A. Then how are actual trig ratios? All of them here are positive. But the other one will ask him or herself, why do they have to give us this one? It could happen that the A is on the fourth quadrant and cos it's positive on the fourth quadrant. But how is sine on the fourth quadrant? Sine on the fourth quadrant and tan are both negative. So that's why they will indicate, actually, they will indicate the sign, or they will restrict the domain in terms of angles. So please be careful of that one. If actually we understand very well what we're talking about, these identities, immediately one student or one learner will recognize the square root of 1 minus cos squared 2a. So since here it's already positive, it's not plus or minus because it was given as positive. So please don't make that mistake. But as long as I see 1 minus cos squared of an angle, I don't see that one. What do I see? We said we see its identity is going to be sine of 2 sine squared 2a. It's come from the fact that sine squared 2a plus cos squared 2a is equal to 1. So through additive inverse, so if I put cos on the other side, sine of 2a will be then equal to 1 minus cos squared of 2a. That's where it comes from. So please be careful of that one. And that's why we had to recall our identities. So this will then be what? So we are simplifying. So it will be then, whenever I see that one, I see sin of squared 2a, all divided by. So cos of a, which quadrant is this? Is the fourth quadrant. How is cos on the fourth quadrant? Cos is positive. So it's going to be cos of a times cos of 90 plus. Cos of 90 plus, which quadrant is that angle? That angle is on the second quadrant. How is cos on the second quadrant? It is my wish. This is how we can actually approach this one. Because to talk to it, it allows you to understand what you are doing. So cos of 90 plus on the Second quadrant, cos is negative, so it's going to be negative. But since we are talking to 90 gave us co-ratios, if you still remember what we did in the first time when we were dealing with trigonometry. So cos will change to what? Will change to sin of A. So please don't forget that one, that cos will change to sin. Now we are simplifying. How many terms do we have here? We have got one term. So since we have got one term, through radical, this radical means that when I've got the square root of x, it means that it is x to the power 1 times 1 over 2. On an exponent, the square root means 1 over 2. Now, in this case, if then we have got x squared, the square root of x squared, it means that it is x to the power 2 times 1 over 2 and 2 over 1, which will then will be what? X 2 times half will be 2 over 2, which will be x. What is 2 over 2? It's 1. So that's why then mathematically we say this one will multiplicatively cancel to this one. But mathematically, this is the process that expression, that sum is following. So therefore, we will be left with what? We will be then left with sin of 2a. Sin of 2a. All divided by. So here, how many terms do we have here? We have got one term. Now, how do you then actually simplify it? You just multiply since it's one term. But since there is nothing for cos, it means the coefficient of cos, which is 1, it is positive. So what is positive times negative? It is negative. Cos A times sin A, it is going to be cos A times sin A. I want to believe that you are still following on that one. So, and then how many terms do we have here? We have got only one term. So since we have got only one term, we can simplify this. However, we cannot cancel here sin 2a and sin A because the angles are not the same. So please take note of that one. For us to divide using the laws of exponents, we must first make sure that the angles are the same. But whenever I see sin 2a, we said we don't see sin 2a, but we see its identity. What is the identity for sin 2a? It is going to be 2 sin a times cos a, all divided by negative sin a times cos a. Wow. Now the angles are the same. What then does it mean? It means that sin A, it will divide sin A because the exponent is 1, the exponent is 1. So whenever you're dividing the powers of the same bases, you keep the base and subtract the exponent. So sin to the power 0 will be 1. Also, same thing applies to cos because it's one term. Now we left with what? We left with 1 here, 1 here. 1 times 1 is 1, 1 times 1 is 1. 2 times 1 times 1, it is 2 divided by negative 1, which is the same as negative 2. So that will be your solution to this one, to be simplified completely. Then you have got your 5 marks. I want to believe that you are still following and you still understand what is it that we are doing. So please be careful of such a silly mistake that we might commit. Now, the other one that I gave you as a homework was 2, without the use of a calculator, but simplify this expression into a single trigonometric ratio. So it means that at the end, you must get only a simplified single trig ratio. How many terms do we have here? In this case, we have got 2 terms. Why? Because of positive or addition that we have. But on the left-hand side, how many terms do we have? We have got 1 because of the division. On the right-hand side of addition, we have got also 1 because of division. So hence, we've got 2 terms. How then do you approach? You treat each one per time, or as you take into that function. So cos of 90 plus x, cos of 90 plus x, since this one is a compound, but there is no need for us to expand since it consists the identity that we might recall, which is a co-ratio. Sin of cos of 90 plus x, it is on the second quadrant. You ask yourself a question. How is cos on the second quadrant? Negative. So it's going to be negative sin of x times cos of x. So sorry, times sin of x. I don't know why I'm writing cos of x now, because this one was just simplified. So times what? Times cos times sin of x. Now plus the very same plus. This one, learners here, please be careful. The meaning behind square of a trig function, when I write sin or cos square of x, since it's a trig ratio, a trig function, it means that this is sin of an angle all square. So it squared the ratio of a function. So also this one, be careful when you actually address it, so that you actually don't lose marks for unnecessary so. So this one then can be expressed as what? It can be expressed as cos of 180 degrees plus x all square. Now, we actually define what is inside the parentheses. So in which angle do we find cos 180 plus x? 180 plus x, it is on the third quadrant. How is cos on the third quadrant is negative? So this is the same as negative cos x all square. So please speak to what you are doing so that you understand it. Now, what is the meaning of square here? It means you are repeating the very same base by itself. So therefore, it is going to be negative cos of x times negative cos of x. What is negative times negative? Positive. What is cos x times cos x? Cos squared x. So yes, indeed, the answer will be positive cos squared x. But the other one will ask, what if I just write cos squared x? And then because the answer, no, the other mark will be allocated to indicate that you understand where do you find the angle given to you, which is on the third quadrant, and cos on the third quadrant is negative. So please be careful of that one. So times tan 200 degrees. So tan 200 degrees, again, you speak to it. Where do you find tan 200 degrees? It is on the third quadrant. How is actually tan on the third quadrant? It is positive. But how do you, before you put it as a ratio identity, how do you define 200? That tan 200 can be expressed as, it can be expressed as tan of 180 degrees plus, then you ask yourself, what angle can I add to 180 to get 100? It is 20 degrees. That's why we actually learn about the reduction. So therefore, this will be what? This will be tan 180 plus 20 degrees. But what is tan 180 degrees? 180 plus 20 degrees, it is positive tan 20 degrees. Now it is reduced. That was the reason why we were learning that. So we go into that one, sin negative 90 degrees. Sin negative 90 degrees, it means that I am now moving in a clockwise direction. In a clockwise direction, the angle is negative. In an anti-clockwise direction, the angle is positive. But we can recall what is sin 90. Since it's a special angle, sin 90, it is equal to what? 1. Why sin 90 is equal to 1? It is because as your angle, the terminal arm opens up, it happens that it reaches what? The y-axis. And this opening, it's informed by what? The radius. So in this case, y and the radius are equal. So therefore, when y equal to the radius, in terms of the radius, we can also put what? Y. So what is y divided by y? It is 1. That's why sine 90 degrees equals to what? Equals to 1. Now, but in this case, it is negative. Since it's negative, it is going to be negative 1. So that is the reason. Now we go to the other one. So tan 340 degrees. Tan 340 degrees, we found in which quadrant? We found tan 340 degrees on a fourth quadrant because it is greater than 270 degrees, but less than what? Less than 360 degrees. So we find it on the fourth quadrant. Now, what defines the fourth quadrant? The fourth quadrant can be defined by, it can be defined by 270 plus or 360 minus. But with 270, please be careful, that will be the core ratio. And I actually don't have a tangible submission to say why then can't we use utan 70 whenever we are simplifying, because it is also doable as long as you understand what is it that you are doing. So therefore we are going to simplify this one as utan of 360 degrees. Then you ask yourself, what angle do I subtract to 360 to get to 40, or add to 340 to get to 360? That will be what? It will be 20 degrees as well. So, but since it's on the fourth quadrant, how is tan there? It is negative. So it's going to be negative tan 20 degrees. I want to believe you are still following. Now, in this one, how many terms in this one? We've got one term. And on the other side, how many terms? We've got also one term. So therefore, what is negative divided by negative? So negative divided by negative will be positive. Since we have got one term on the numerator, then we can just multiply the numerator with the numerator. What is sin x times sin x? Will be sin squared x. So don't forget that one. So again, also here, since we have got one term, this tan 20 and tan 20 can actually divide each other since it's one term on the left-hand side of equal sign. Then we left with what? Here we've got -1. Since we have divided, we left with -1 because here it will be 1. So cos squared times 1, it will be cos squared x. 1 divided by 1. So since cos squared is positive and this one is negative, it is going to be negative cos squared x. Hey, why am I writing a now? It's going to be negative cos squared x. Now, please be careful when it's come to this one. It's cos squared x. There are some misconceptions that can develop here. Remember, with the square identity, it must be sin squared of x plus cos squared of x that can give us 1. But in this case, it is negative. Please be careful of that one. The other identity that we can recall, it is supposed to be cos squared of a or x minus sin squared of a. That can give us what? Or cos 2a. And in this case, sin is positive and cos is negative. Hence, it is not in this form of the identity. And that's why I say number 13 when you are dealing with trigonometry is very important. So how then could we actually manipulate it into something that we know? We can take out the common factor here. And what is the common factor here? It is -1. So when we take out the common factor of -1, so positive divided by negative will be negative sin x. Negative divided by negative will be positive cos squared x. Also, this one is squared. Now, with this one, through commutative property, we can express it as negative into cos squared of what? Of x minus this negative, minus sin squared of x. Now, with this one, we can say that this one is exactly the same as this one now. What then does it mean? It can now define the the double angle identity because it is in that fashion. So therefore, we can make our conclusion to say, oh, now since it is in that manner, therefore it's going to be negative cos 2x. Now it is simplified as a single trig ratio. So that's how easy we could have done that one. And then one, if you like, you can change the sign of them and express it in terms of cos. It will be still doable, or you can express cos in terms of sign using this one. But at the end, with the other two identities, you are still going to get one and the same answer on it because it will be the same. Because if we put cos here, it will be 1 minus actually cos squared. So when you manipulate that one, it will take us back to what? It will take us back to 2 cos squared of x minus 1. What is 2 cos squared of x minus 1? It is cos squared, cos 2x. Again, if you substituted cos by sine, it's going to be 1 minus sine squared x. So 1 minus 2 sin squared x. Again, it takes us to that one. So it doesn't matter which one, as long as you understand that now when I get into this space, I'm applying the identity. And then the other one, If it's a condition, if sin of a plus b equals to 1, sin of a plus b equals to 1, and cos of a minus b equals to actually the square root of 3/2. I want to believe that in this case, where b is greater than, when a is greater than b, of course, determine the value of a and b. So here it's an application of your special angles, learners. So it says, when I interpret or paraphrase it, what angle must a plus b of sin that can give us 1? What angle must be a minus b, of course, that will give us the square root of 3/2. I want to believe, I just spoke about it. We all know that sin of 90 degrees equals to 1, as well as cos of 30 degrees is equal to what? The square root of 3/2. So this must be 30 and this must be 90 degrees. I want to believe we are still actually understanding that one. Therefore, what then does it mean? It says a plus b must be 90 degrees for this to be true, as well as what? A minus b must be what? Must be 30 degrees to get the square root of 3/2 for cos. Now, once you have got this, you can solve simultaneously in many ways. There are many ways to do this one. The first one, I will say, one student will say, okay, now I've got simultaneous equation, but this and this are the same. So when I say a plus b plus a minus b is equals to 90 plus 30 degrees. So a plus a will be what? Will be 2a. B and B will cancel each other because of the sign. Therefore, it will be equals to 120 degrees. I divide by 2, I divide by 2. So therefore, A must be what? Must be 60 degrees. Alternatively, the other student will solve his or her A by doing what? By making one of them a subject, which is also correct. So one student will take equation 2 to say A is equals to 30 degrees plus B. The student actually took this one to the other side through additive inverse to make A a subject and substitute this one into equation 1. So that's what the other student will do to solve for A. So therefore, whenever I see A, I don't see A, but I see 30 plus B. So therefore, equation 1 will be read as what now? Equation 1 will be 30 degrees plus B plus B is equal to 90 degrees. So therefore, this will be what? It will be 30 degrees plus 2B is equal to 90 degrees through additive inverse. This will be 2B is equals to 60 degrees divided by 2 divided by 2. So therefore, B equals to what? Equal to 30 degrees. However, the other student to solve for B will take n of this equation and solve. For B, we'll then take this one and substitute here 60 degrees for A. So once you substitute 60 degrees for A, again, it will be easy for that student to solve for B in this one. So therefore, that student will, that's what? That student will then actually saying B through additive inverse, B will be then equals to 90 degrees minus 60 degrees. I want to believe that you are still following. So that is the other way to do it. And then once you have got a B in this one, that student will take this 30 degrees and substitute in the value of B there. So therefore, what will be 30 plus 30? It will be 60 degrees. So these are the different methods that you can use to solve the very same equation. I want to believe that you are still following, and then you can just manipulate and play with actually such equations the way they set it. Now, I said we must actually able to integrate the patterns whenever you are dealing with actually problems. There is this one which says calculate the value of sin squared 89 plus sin squared 88 plus sin squared 87 With the 3 dots, I want to believe that we all understand that it means continuation, plus sine squared 3 degrees plus sine squared 2 degrees plus sine squared 1 degrees. It means this one was the starting and this one was the end, since there are 3 dots in between. Now, the first thing that we should ask ourselves here, how many terms do we have in this one? We can say that we have got from 89 to 1. If we count from 1 up until 89, we can all agree that we have got 89 terms. So one student in this one might be actually misinterpreting this one. Why am I saying that? Because if you look at the angles, 88, 89, so there's a difference of 1 here. So 88 minus 89 is -1. 87 minus 88 is -1. 2 minus 3 is -1. 1 minus 2 is. So there is an arithmetic in terms of angles. However, we cannot use the sum series for arithmetic series, which is over 2 into what? Into a plus into n minus 1 times d, or the other one, which will be n over 2 into a plus the last term. We cannot use this one. Why we cannot use this one? It is because for this to be a function, an angle and this one do not get separated. It is a function, it is a trig function because it goes with an angle. So please be careful when it comes to this one. It is the definition that we are using. I want to just to address that one to say, please, it is also important to make sure that we apply the concept on what we are dealing so we can contextualize it. It is very much important. How then can we actually approach this one? When I look at the first term and what? The last term. The first term and the last term, if I add their angles, interpretation, so I get what? 90 degrees. If I take the second term and the second last term and I add their angles, I also get 90. If I take the third and the second to last, I also get what? 90. But what is sine 90? Sine 90 is 1. Oh, how many terms do we have? 89 terms that we have. Then what then does it mean? It means there is a relationship of the first term and the last term that can be added to give us 1. But we cannot again take sin squared of 89 degrees plus sin squared of 1 degrees. Then we say there's a common factor here. And then which will be what? Which will be sin squared of 89 degrees plus 1 degrees. So which will give us what? Which will give us sin squared of 90 degrees. Hey, that's meant for you. Which will be sin 90 all squared equals to 1. I don't know. How can I actually express this? This is a misconception. Why? An angle and its function do not separate. So we can't say there's a common factor between these two. So please, the answer, yes, you get 1. But mathematically, the context does not allow that one. So please don't get into that trap of misconception. Then what is it that I need to do? Know your identities. Know your identities, and that is the reason why I actually emphasize the identities. What we know that in this case, the very same sin of 1, it can be expressed correctly so. Sin of 1 is the same as what? Is the same as 90 minus. 90 minus what? 90 minus 90 minus 89 degrees. Now, what is 90 minus 89? 90 minus 89 is 1. And that is correct. Again, do you see that we cannot distribute sin here because it is not a common factor? Plus, this one can be written as what? It can be written as sin 90 degrees minus what? 90 degrees minus 88 degrees. What is 90 minus 88? It's 2. again, when you look at this one, it can be expressed as sin 90 minus 87 degrees. What is 90 minus 87? Is 3. However, what is sin 90 minus? Remember, these now are squared. So sin 90 minus will be what? Will be cos 89 degrees. Sin 90 minus will be cos 88 degrees, which is squared. And then sin 90 minus 87 will be again cos squared 87 degrees. So do you see that one? Yes, I can recall my pattern. Now, before the dots, I've got these values, and after, sorry, before the dots, I've got this term. After the dots, I've got this one as well. So it means that if I take my last term and the first term and add them, then I can get what? 1. So since there are 89 terms, what then does it mean? I have got 44 pairs that I can add to get 1. So therefore, that will be 44 ones that I will be adding. So I can then express it as what? As 44 times 1. But in the middle of that one, since they are going in pairs, there is a sum that actually, or there's an expression that is not, doesn't have a pair. And then that one, since it's in the middle, will be sine squared 45 degrees. So therefore, here it will be plus sin squared 45 degrees. And this one will be what? Will be the special angle. So what is sin squared 45 degrees? It is going to be 1 over root 2 all square, which will be 44 plus 1 over root 2 all square will be half. So we all know that 144 plus half is going to be 44.5. Without the use of a calculator, yes, we know that if we take 44 and then we add half, it's going to be 44.5. So I want to believe that we also know that one. Alternatively, it can be it can be 89 over 2. So therefore, it is the same as 89 over 2. So that will be also our answer to this one. So we were also asked to say, after we have actually, I actually added my sum, after we have proved that identity, of course, we were then asked to prove the identity. I'm sorry to this one because I've just added. So to prove the identity is to prove that the left-hand side equal to the right-hand side. How then can we prove it? We follow what we did last time. If we look at this one, the angles are not the same. So therefore, cos of 90, if we take our left-hand side, so why this thing now is not writing? If we take our left-hand side, cos of 90 minus x, by now we just know that will be sine x times cos y. Sin of negative y will be negative sin y, because negative times positive will be negative. Now, cos 180 plus, we all know that cos 180 plus, it's on what? It's on the third quadrant. How is cos on the third quadrant? It is also negative. So negative times that negative will be positive cos x, all divided by cos x. Now, 360 plus, it's on the first quadrant. How is cos on the first quadrant? Is positive. It's going to be cos of y. Now, again, this one is going to be plus sin 360 minus. 360 minus, it's on the fourth quadrant. How is sin on the fourth quadrant? Is negative. Negative times positive will be negative sin x, not y. It's going to be sin x. It's going to be sin x times sin y. Now, if you look at the numerator, it is sin x cos y plus sin y cos x. What comes into my mind, it actually gives me the compound identity for sin, because it says sin cos sin. Through commutative property, you can manipulate this one. So that one, therefore, it's going to be what? It is going to be sin of x plus y. I want to believe that you understand that one. All divided by cos of x times cos y minus sin of x times sin of y. As you can see here, it says cos, sin, sin, with the change of sign. Therefore, it's supposed to be cos of x plus y. Again, here we are applying the ratio identity. Whenever I see sin over cos, I don't see sin over cos. But what do I see? I see tan of that angle, only if the angles are the same. So do you see that the left-hand side is exactly the same as the right-hand side? Then we have got 5 marks. So we work with identities at all material times. So I want to believe that, student, you are still following. So the other one that I would like us to prove, it says to us, prove that 1 over sin x plus cos x equals to sin x plus cos x, all divided by 1 plus 2 sin x cos x. On both sides, we have got one term because of division. On the numerator on the left-hand side, we have got one term. On the numerator on the right-hand side, we have got 2 terms. How then do I actually approach this one? I can work with simplification. In this case, since on the other one I started with the left-hand side, let me see if I start with the right-hand side in this case. So if I start with the right-hand side in this case, I'm going to say, I'm working with the right-hand side, which says that sin of x plus cos of x all divided by 1 plus 2 sin x cos x. I said, whenever I see 1, I don't see 1, but I see its identity. So therefore, this can be just quickly said to say it is sin x plus cos x all divided by, that one is the same as what? Is the same as sin squared x plus cos squared x plus 2 sin x cos x. Then I can further simplify this one. How do I simplify? I try to create one term on the denominator. So therefore, it's going to be sin of x plus cos of x all divided by, I can factorize this one. I can express it as sin of squared x plus 2 sin x times cos x plus cos squared x. This one, it is a trinomial. So therefore, to factorize this, we can open the parentheses twice. Therefore, it's going to be sin x plus cos x times sin x plus cos x. We can see that if we distribute here, we're going to have sin times sin, sin squared. Sin times cos, sin cos x. And then cos times sin, it's going to be sin cos x. Sin cos plus sin cos, it is 2 sin x cos x. Cos times cos, it will be cos squared x. So therefore, this is the same as this. So I want to believe that we are all following on this one. Now, since we are multiplying the powers of the same basis, what then does it mean mathematically? Since we are multiplying the powers of the same basis on our denominator, we can actually keep the denominator and add the exponent. What then does it mean? We are going to have sin of x plus cos of x all divided by sin of x plus cos of x all squared, which is the same as this one. Now, how many terms do we have on the denominator? We've got one term. Now, it's exactly the same terms. So one of these can cancel one of these. Alternatively, you can say one of these can cancel one of these. It is still the same thing. Then you left with what? You left with 1 over sin x plus cos x, which is exactly the same as what is on our left-hand side. So we have proved both identities using the left-hand side and using also the right-hand side. It is vice versa. Alternatively, you can also sometimes expect it to prove them working what side on the left-hand side as well as on the right-hand side, but not at the same time. You work on one side, you finish it, you work on the other side, you finish it. Then afterwards, you can make a conjecture or the conclusion whether they are equal or not. Having said that one, it's actually a pleasure to have you, all of you, when we are looking this one together. Now, I will recall my partner in crime to come and assist us actually with the other one, which will be the identity, which will be the equations, and then we will see how far we can go with that one. And then let me just quickly finish this one, and then while my partner in crime actually prepare himself. We are given this function whereby it says calculate the maximum value of G, and then this is the graphic, good people, it says here at x equal to. What then do we have to understand? In this one, we have to understand that one, actually, this is a function, we need to simplify it. But we don't know this. Do we have a common factor here? Yes, we do have a common factor. The common factor, it is 4 in this one into 1 minus 2 sin squared x, all divided by 3. Now, when I see this, I don't see this, but I see its identity. What then does it mean? It is 4 into 1 minus this one, it will be what? Cos 2x over 3. Now, this one is a function, graphically so. It says in a graphically perspective, actually that graph, we are going to have two graphs at an interval of 360 degrees. So the amplitude, therefore, will be what? 3 over 4, because now will be simplified. So therefore, the maximum of this graph will be what? The maximum will be 4 over 3. Now, write down the smallest possible value of x for which G will be have its maximum. Be careful in this one. 0 is excluded, but 360 is included. So in which interval actually will be the graph has the maximum, and that value will be the smallest. If we go this one, the graph here is its maximum at 4 over 3, and here it's its minimum at negative 4 over 3. But also here it's at 4 over 3. Also here it's at 4 over 3. So it says which one, what are you doing now? It says which is the smallest one amongst the three. 0, 1, 8, and 360 will give us the maximum. 0 is the smallest, but is not included on our solution. 360 is also the one that gives us maximum, but is not the smallest. Hence, the answer here will be 180 degrees. Then you have just answered the question. So thank you very much for your time, and then I hope you have learned a lot, and then we want to believe that you are commenting on your chat box, and then we would also appreciate your feedback. Thank you very much for today. Over to you, Osian.
Thank you, Mr. Ntuli. Good evening, everyone. As I'm still trying to open my document here. We are going to be looking at the trigonometric equations. Yeah, so we are going to be looking at the trigonometric equations together, determining the general solution. I hope you were paying attention to what Mr. Ntuli was doing, because most of the things are going to be required here as we are doing the general solutions together. So allow me then to start as I've managed to connect my PowerPoint presentation. So we are going to be doing together the equations. Here I have this clock. I want us to look at this clock very carefully. you can see that it is indicating that right now it's 10 o'clock. It's indicating that it is 10 o'clock. So my question will be, if it is exactly this time now, when will the clock hands look the same again? So that is my question to you. If it is right now, if it is 10 o'clock, when will this clock, or when will the clock hands look the same again? Now, if we take note of this clock, you can see that we will have to move to 11 o'clock, which is 1 hour. We'll have to move to 12 o'clock. We'll have to move to 13. We'll have to move to 14. We'll also have to move to 15, move to 16, 17, 18, 19, 20, 21, and 22. So when it is 22 hours, then the clock hands will look exactly the same as they are looking right now. So you can see that it took 12 hours for the clock to return to its position, for the clock hands to look the same as they are right now. As it is now 6 o'clock, it is now just after 6 o'clock, but let's say it was 6 o'clock right now. Let's make an example and say right now it is 6 o'clock. I want to believe that my clock hands will look like something like this one. This is how my clock hands would look like if it is 6 o'clock right now. But these clock hands will have to look the same after 12 hours again. I'm sure that will be, if it is 6 o'clock now in the evening, so it will be 6 o'clock again in the morning. So basically, that's how general solutions work, because in your trigonometric ratios or your trigonometric functions, angles behave exactly like a clock. After every full revolution, there is a new position, but the value will always be different. Let's take, for an example, sine 80 degrees, which we know that is equals to 1 over 2. In our unit circle, let me move fast to our unit circle. In our unit circle, you know that we have 4 quadrants. So in our 4 quadrants, there is the first quadrant where all our trig ratios are positive. It is all are positive. Then there is the second quadrant where sine is the only one that is positive. Then there is a third quadrant where tan is the only one that is positive. And then we also have the fourth quadrant where cosine is positive. Now, I was talking about sine 30. If we have sine of the angle, which is 30 degrees, let's say it's somewhere here. Let's say this angle that is open here is 30 degrees. Now, if this angle is 30 degrees, we know that when we move anti-clockwise 360 degrees, we'll return to this exactly, to this point exactly where we were. But we would have added 360 degrees, which will then give us 390 degrees. Even if you check using your own calculator, sine 390 degrees as well as sine 390 as well as sine 30, they will give you the exact answer, which is 1 over 2. So when you check sine 30, it will give you 1 over 2. When you check sine 390, it will also give you 1 over 2. So we can go around again And then we add another 360 to 390 plus 360. We'll then have 750. And then that will also give you the same value. Now, going back to the general solution, it means it's a way of showing all possible answers for a trigonometric equation, because we know trig functions, they repeat after every cycle. So a general solution is just a way of showing all possible answers for a trigonometric equation, because we know that trig functions, they repeat in every cycle. So what is important here is to also to remember that in each and every quadrant we have what we call reduction formulas, which my colleague Mr. Ntuli did indicate to us that in each and every quadrant we have a different reduction formula. Like in this quadrant, we know that in the fourth quadrant is 360 minus an angle minus theta. We know that here we have our angle, which is theta, our acute angle. And we know that when we move in a clockwise direction, it will be minus theta here. And in the second quadrant, it's 180 degrees minus theta. And in the third quadrant, it is 180 plus theta. So it is important to take note of these reduction formulas, or to remember these reduction formulas, as you are going to be needing these reduction formulas when we are dealing with, or when we are solving trigonometric equations, or dealing with our general solutions. So these are the questions that you need to ask yourself before you even begin, before you start attempting to solve a trigonometric equation. You should be asking yourself some of these questions. Can I simplify? Is there something that I need to simplify first before I solve my equation? Can I factorize it? When you look at your equation, is it possible for me to factorize? Is there a highest common factor? Is it a quadratic equation? Can I factorize? Is it a difference of two squares? Is it possible to factorize this equation? These are the questions that you need to ask yourselves before you even attempt to solve the equation. Can I use the identities? Mr. Ntuli was talking about the identities. Is there an identity that I see? Then if the answer is yes, then you'll have to make use of those identities. Can I convert to one trig function? Is it possible to convert maybe from sine, you have sine as well as cos? Is it possible to divide by cos and get one trig function, which is tan? If that is possible, then you'll have to apply it in making sure that we are solving these equations. Can I use trig ratios? Those are the questions that you need to ask yourself before you even start attempting solving trigonometric equations. Is this a double angle? Is there a double angle? Is there a compound angle? So these are the questions that you need to ask yourselves before we attempt to do these equations. I have one of the examples. It's just a basic one. I'm sure we are all familiar with this one. It's from grade 10. In grade 10, when we were introduced to trigonometric equations, we were introduced to an equation which looks exactly the same as the one here. When solving trigonometric equations, we say we always have to isolate the trigonometric ratio parts. So this is the equation. It's like we are warming up for grade 12 equations, but it's important that we start at this level. So we have 2 cos theta minus 1 equals to 0. So we said we need to isolate first. So you will have 2 cos theta equals to 1, because we'll add 1 on the left hand side. We also add 1 on the other side, which will then give us 2 cos theta equals to 1, and then we'll have to divide by 2 on both sides. Then we'll be left with cos theta equals to 1 over 2. Because when we are solving these equations, we are looking for this angle. We are looking for this angle, which is theta, which is going to give us 1 over 2. So we are looking at this at that angle, which is theta, and we know there are many possible angles. There are many possible values of theta that can give us 1 over 2. So basically, that is an idea of trigonometric equations as well as finding the general solution. So what will be the angle that is going to give us 1/2? We'll then have to press shift, or then we have arc sine equals to 1/2, and then arc cos, forgive me for that one. So we say shift, and then we press then 1/2. It should give us 60 degrees. So we call this angle 60 degrees our reference angle. So that will be our reference angle. So our reference angle here is 60 degrees. Now, looking at our cos, because it's very important to take note of your answer, our numerical value here was 1/2. And if it is 1/2, we can see that it is positive. So now the critical part now when writing now your solution, your general solution, is looking at the sign of your ratio. Looking at the sign of our function here, it was 1/2, which is a positive 1/2. And remember, when we spoke about the cast diagram earlier, we said that in our cast diagram, we know that cos is positive in the first quadrant as well as in the fourth quadrant. So I have already indicated here, if you look at this part in our screen, there are general solutions which we use for cos as well as for sine, because we know the period of cos and sine, it's 360 degrees. So it takes 360 degrees for cos to complete a revolution or complete its wavelength, and it also takes sine 360 degrees to complete its wavelength. So that's why in our general solution for the first quadrant, it's theta equals to the reference angle plus k times 360, where k is an element of all integers. So we said it takes 360 degrees for sine and for cos to complete its wavelength or the revolution. So to get the next possible answer, you will have to move 360 degrees. So as you can see here, we have our reference angle as 60 degrees. Now, if it is 60 degrees, then we know that cos is positive in the first quadrant, and it is also positive in the fourth quadrant. So we are going to use the solution for the first quadrant, which is over there in our screen. The first one, it will be theta equals to the reference angle, which is 60 degrees, plus k times 360 degrees, where k is an element of all integers. So that would be our first solution. Then our second solution will definitely be found in the fourth quadrant, because cos is positive in the fourth quadrant. So there it is. We have theta equals to 360 degrees minus the reference angle. Our reference angle is 60 degrees, so it will be minus 60 degrees plus k times 360, where k is an element of all integers. So that's how you would go about determining the general solution for this basic equation that I had with me here. So let me quickly move to the next one. Remember, there are questions that I said you need to ask yourself first. You check whether is it possible to factorize. Is it a quadratic equation? If it is a quadratic equation, then you must write it in a standard form. So that's what you need to ask yourself before you start trying or attempting to solve your equation. So our example number 2 is factorizing the quadratic equation by taking out the highest common factor. You can see that we are given this equation, which is 2 sine squared theta equals to sine theta. So this is our equation. For us to solve this equation, it's clear to see that this is a quadratic equation. So we'll have to write it in a standard form. How do we go about it? We transpose sine theta to the other side, and then its sign will then change to become a negative, and then equate it to 0. Now we have 2 sine theta minus sine theta, and it is clear we have 2 sine squared theta minus sine theta. It is clear to see that we have a common factor. If you look at the one term here, 2 sine squared theta minus sine theta, you can see that there is a common factor. We'll then factorize by taking out this common factor, which is sine eta into, you are going to be left with 2 sine theta, and then we are going to say minus 1 because we are only left with minus 1 inside. And then now we have our factors, then it's going to be sine theta equals to 0, or 2 sine theta equals to 1. Then we are going to divide by 2 on both sides, divide by 2, divide by 2. Then sine theta is equals to 1/2. So we now have the numerical values with us. The first one is sine 0. Then to be safe, even though we should know this, but to be safe, we are going to check using our calculators. Even our graph can tell us, because we know the graph of sine. We know where it is 0, and then we know that it is 0 here. It is also 0 here, and it is also 0 there. So if we check, we say shift sine to find our reference angle. To find our reference angle, both of these reference angles will also use 1/2, and then we are going to have 0. As we said, we know that sine is 0 here. It is also 0 here at 180. It is also 0 there at 360. So that would be our answer. So our reference angle. Then when sine is 1/2, I think we have already calculated that one. We said it's going to be 30 degrees, but you can check using your own calculator. Then sine 1/2 should give you 30 degrees. So these are our reference angles, because before we go to our solutions, we must have the reference angles that we are going to be working with. So again, when you check here, sine is 30 degrees, the reference angle is 30 degrees, but you can see that our answer is 1/2. So sine is positive. So it means sine is positive. And when sine is positive, you go and check which quadrants is sine positive on. We have a quadrant where sine is positive. Then we need to go and check which are those quadrants. Which are those quadrants where sine is positive? Sine is positive in the first quadrant because all trig ratios are positive here, and sine is also positive in the second quadrant. So we are going to be using the second quadrant as well as the first quadrant general solution formula. Then let us use these formulas then to get our answer. Then for the first quadrant, we said it's going to be theta is equals to 0 plus k times 360 degrees, where k is an element of all integers. We said also 180. We saw that sine is also 0 at 180. It's also 180 plus k times 360, where k is an element of all integers. And then for this reference angle, again, we are going to find our solutions, because sine is positive on the first as well as on the second quadrant. So our general solution will be theta equals to 30. For the first quadrant, we are using this one, is equals to 30 plus k times 360 degrees, where k is an element of all integers. I hope you are still following. And then we are also going to use this reference angle, because sine is positive on the second quadrant. We are going to say 180 degrees minus 30, where k is an element of all integers. So our general solution will then be 150 degrees plus k times 360 degrees, where k is an element of all integers. So it is important to take notes on your equation. Take notes of your equation. Take note of your equation, how it is formulated. Check whether it is possible to use identities. Check whether it is possible to use correlations. Check whether they are double angles. Check whether they are compound angles. So the most important part is being able to see exactly how your equation is formed, how your equation is formulated. So then you would know which strategy to use in order to solve the equation. Let us move to the next equation. Our next equation, we are required to solve this trig equation. It's 2 cos squared theta equals to sine theta plus 1. So again, we are going to be doing the very same thing. It's clear again to see here that we have a quadratic equation, but now if you take note, or if you look at this equation very close now, you will see that now you have sine, you also have cos, unlike in the other previous one where we had both terms were written as in terms of sine. Their trig ratios, what that was written was sine. So here it's clear to see this is a quadratic equation, so we must write it in a standard form. So the first step for us is to write this equation in a standard form and see whether it is possible then to factorize or do any other thing. So we have 2 cos squared theta minus sine theta plus 1 equals to 0. Now, when you look at this equation, you can see that you now have cos squared theta, but here your other term is sine theta. So if it is possible to make it to be cos throughout or to be sine throughout, then that is what we need to do. As you can see here, we have cos squared theta. We have cos squared theta, and we know that cos squared theta is an identity. Cos squared theta, we know that it is equals to 1 minus sine squared theta. So whenever you see cos squared theta in your mind, you should know that it's still the same as 1 minus sine squared theta because it is an identity. So that's what we are going to be doing so that we make sure that our equation only consists of sine. So we are going to change cos squared theta and write it as 1 minus, we are going to write it as 1 minus sine squared theta. 1 minus sine squared theta minus sine theta plus 1 equals to 0. And then we are going to simplify by distributing these two. It will be 2 times 1. It's going to give us 2. And then 2 times minus sine squared theta. It's going to give us negative 2 sine squared theta minus sine theta plus 1 equals to 0. Again, it's clear to see that now we have a quadratic equation which is in the standard form, and everything now is written in terms of sine. We then have to add these two values. Then they are going, because we have the like term here, 2 plus 1, it's going to give us 3. So it's sine squared theta minus sine theta plus 3 equals to 0. So we have minus 2 sine squared theta minus sine theta plus 3 equals to 0. And we can see that this is a standard, a general equation which is written in a standard form, a quadratic equation in a standard form. For some of our learners, I'm sure it becomes very easy when you now write it as an equation that we are more familiar with. Most of the learners would prefer letting sine theta equals to x. So if you do that, then it will become your normal quadratic equation, which you can even use a quadratic formula to solve, because you would have seen that no, it's a general quadratic equation. So if you do that, if you let sine equals sine theta equals to x, then it will be negative 2x squared minus x plus 3 equals to 0. Then we are going to factorize using by opening two brackets, factorizing the quadratic. Maybe before we do that, we know it's important to divide each term by negative 1 so that our value of a becomes positive. So we will have 2x before we do our factors. Maybe before we do our factors, let me erase here so that you can all see. Let us do this. Then if you divide by negative here, you are going to be having 2x squared, which is positive. Divide by negative 1 here, you're also going to be having positive x. Then it's going to be minus 3. Then for us to get the factors here, we know that the factors of 2x squared, it's going to be 2x and x. And for us to get 3 and also to get the middle term there, we will have to have 3x as well as 2x. So it needs to be 1 here because our middle term is positive. It's positive. So then it means our 3x should be positive and then our 2x should be negative. So when you multiply 2x multiplied by x, we are going to get 2x squared. When you multiply 2x and negative 1, we are going to get negative 2x. And when you multiply positive 3 and x, we are going to get 3x. And when you multiply 3 and negative 1, we are also going to get that negative 3. So we can see that our factors are correct. So now what is required of us now is to solve our equation. 2x plus 3 equals to 0 because we now have factors. Then x minus 1 equals to 0. Therefore, x is equals to negative 3 over 2. We're going to move our 3 and become negative and then divide by 2. Then x is also equals to 1. Remember, we are not just looking at x. That we said our x is equals to sine. I think now we can now replace x as sine theta equals to negative 3 over 2 or sine theta equals to 1. So those will be our values. Sine theta equals to negative 3 over 2. Also, sine theta equals to 1. Then we need to find now the general solution. Now we need to find the general solution using these two. We know that sine theta equals to negative 3 over 2. That should be undefined because negative 3 over 2, that is 1,5. And sine theta, the maximum as well as the minimum, it should be between negative 1 and 1. But we can try. Let us check it together. You can put it in your calculator. Say shift, and then you put sine. Then you also put 3 over 2. It should be math error. It's going to be undefined. Why is it undefined? Which is also very important to take note is that we know that sine theta has the minimum as well as the maximum. Sine has the minimum at negative 1 and the maximum at 1. So you can see that to negative 3 over 2 or 3 over 2, that is 1,5. So it means it's outside of the range that we have, which is negative 1 and 1, unless there is a shift of some sort. So then we are going to scratch this one out. Then we are going to be using sine theta equals to 1. Then we know, again, you're going to go to your calculator, press shift, press sine, and then you check what is your reference angle. Our reference angle is going to be 90. In terms of the graph, I'm sure we will all see when we are doing trigonometric functions why sine theta equals to 1 is 90 degrees. So it's going to be 90, and then we are going to be using this one, and then theta . Sorry about that. Then with theta, our theta is going to be 90 plus k times 360, where k is an element of all integers. So I'm just writing 90. Plus k times 360, where k is an element of all integers. So that will be our solution. Now let us move to the next one. As you can see now, we have the equation, which is 3 sine theta plus 4 cos theta equals to 0. Now you can see that this equation is in a different form now. It's no longer the same as the previous one. It's a different form. With this one, what you need to take note of is that you have two different trig ratios, and it is not possible here to use the trig identities. But here we can then divide by cos both sides so that we change into a single trigonometric ratio, because we have two different things here. We have 3 sine theta plus 4 cos theta. 3 sine theta plus 4 cos theta equals to 0. So what we need to do here is to transpose this part to the other side. 3 sine theta equals to -4 cos theta. Once you have this type of equation, you then apply what we said you should be asking yourself earlier. Is it possible to work with a single trigonometric ratio? Is it possible to work with one trig ratio? Here you have sine, you also have cos. So what you do here, it's very simple. You just need now to divide by cos on both sides. Then it will give us our identity that we know that sine over cos is equal to tan. So we then now move to that identity, because now we have sine over cos, which is now going to change to sine, and then cos will divide to cos, and then this will be equal to 4. Now, since this is equal to 4 and we are looking for tan theta, we then have to divide by 3 on both sides. When you divide by 3 on both sides, you are going to get tan theta equals to -4 over 3. Now, when you have tan theta equals to -4 over 3, you then have to check the reference angle, because we now have the numerical value, which is -4 over 3. We then have to check what is our reference angle, and then we are going to check what is the sign here. It's negative. So if it is negative, then we are going to use a general solution for the second quadrant, because tan is negative on the second quadrant. We are also going to use the fourth quadrant, because tan is also negative on the fourth quadrant. But please take note of this. We are not going to use 360 degrees, because the period of tan is not 360 degrees. The period of tan, in fact, it's 180 degrees. The period of tan, because we are looking at tan now, it's 180 degrees. So for cos and sine, the period is 360 degrees, but for tan, the period is 180 degrees. So it means tan completes its full cycle in 180 degrees. So tan completes its full cycle in 180 degrees. So our general solution should also indicate that the period for tan is 180 degrees. So we are going to be looking at our reference angle. You are going to go to your calculator, you press shift, then you press tan, then that will be your arc tan equals 4 over 3. Please take note that we don't include negative when we are looking for the reference angle. Negative is just there to guide us in terms of the quadrant that we are going to be looking at. So you don't put the negative. You just put 4 over 3, and then you are going to get 53,13. That should be our reference angle. Our reference angle is 53,13 degrees. So if that is our reference angle, then we then move to the first quadrant. We know what we need to do in our first quadrant. Theta is equals to the reference angle, which is 53,3 plus K times 180 degrees, where K is an element of all integers. So this will be our first solution for the second quadrant. And then we said tan is also negative on the fourth quadrant. So we do have the general solution for the fourth quadrant with us here. It's theta equals to 360 degrees minus the reference angle, which is 53,3 plus K times 180 degrees, it's 360, because we are dealing with tan. It's plus k times 180, where k is an element of all integers. So these will be our general solutions for that equation where we were required to change and use a single trigonometric ratio. Let us move to the next one. I hope you are still following. If we move to the next one, this is an equation, or these are types of equations which are written in this form. So it's important to take note of the form, because you must be able to identify patterns when you are dealing with trigonometry. When you look at the equation, then you should be able to recall then how to approach this type of an equation, because they are different types. They are written in different formats. So you should also be able then to know by looking at it, with, okay, this is how I'm going to deal with this one. So this one here, you are given a ratio, which is if sine A is equal to sine B, then it means B is you take B as your reference angle. And then if it is given in this form, then you know that since here it's positive, then we are going to be looking at the first quadrant as well as the first quadrant. This one represents the first quadrant as well as the second quadrant, because our sign is positive, as you can see. So this is how you approach this type of a problem. If it is given in a form of sine A equal to sine B, then for these two to be equal, then it means these two angles must be equal, because you are given the same trig ratio. You are given sine of an angle, and we are also given sine of an angle. So for this equation to be correct, for these two, for sine A to be equal to sine B, then it means A must be equal to B. This means these two angles must be equal. Then we use this general solution for the first quadrant, and we take our B here. We take B as what? As our reference angle. We take B as our reference angle. So if the equation is given in a form of sine A equals to sine B, we then say, therefore, A should be equal to B. Ngoba, for this to be true, it means these angles must be equal, as you can see. These angles must be equal, and B, we take B as our reference angle. So then how would you go about solving this equation now? So you can see that we are given same trig ratio, sine of an angle equals to sine of an angle. We are given sine of an angle equals to sine of an angle. So what you need to do then, you need to apply what I've just explained now. For these two to be equal, it means this angle must be equal to this angle. This angle here must be equal to the other angle. And you let this theta be your reference angle. Our reference angle here is this angle, which is theta. So what we are going to be doing is very simple. We are going to take this angle, which is theta, minus 20. Then we are going to say sine is positive in the first quadrant. So in the first quadrant, it's a reference angle plus k times 360. So we are using this one. So we're going to bring down theta minus 20 degrees equals to our reference angle, which is theta plus k times 360, where k is an element of all integers. So it's then one of the easiest type of equations that you will ever find with trigonometry. So you just now need to transpose these two, then you will be left with theta equals to, then it's going to be, or you're going to transpose the other theta to the other side, then it's going to be negative. You are going to move theta to this side, then it's going to be, because we have theta minus 20 degrees. So when you move this theta to the other side, it's going to be theta minus theta, which is going to be 0, equals to, you transpose 20, it's going to be positive. When you move 20 to the side, positive plus k times 360, where k is an element of all integers. So you can see that 0 cannot be equal to this. So there is no solution here for this quadrant. And then we are going to use again another solution for the second quadrant because the sign is positive. So you will be using these two. Then for the other solution, which is this one, for A, which is our angle theta minus 20 degrees, is equals to 180 degrees minus B, which is our theta, our reference angle, minus our reference angle, plus K times 360, where K is an element of all integers. Then you are going to solve again. Theta, we are going to take with theta to the other side. It's going to be 2 theta equals to, if we take with 20 to the other side, it's going to be 100. So it's going to be 200. 180. 180 plus 20. 180 plus 20. It's going to be 200 plus K times 360, where K is an element of all integers. And then you are going to divide by 2 because we need to theta to be alone here to be the subject. Then we are going to divide by 2, divide by 2, divide by 2. Then when you divide by 2, you'll be left with theta equals to 100 degrees plus K times 180 because we have divided everything by 2, where K is an element of all integers. So that's how you would go about solving this type of an equation. I hope it does make sense. What you need to do is to identify, just look at your equation carefully and see and ask yourself those questions. Is it possible for me to factorize? Is there an identity? Is there a double angle? Now here I'm given sine of an angle equals to sine of an angle. Therefore, I need to equate my angles because they are equal. And then I will have to use one as my reference angle, and then you should be fine. Moving to the next one, which is exactly the same as the previous one. But now I wanted to emphasize this one here, this negative. As you can see, this negative sign, here, it's very important to take note of this one. We are given cos A equals to minus cos B. So this negative here represents the quadrants where cos is negative. So we are still going to be applying the very same method. We said if cos A is equals to cos B, then it means B should be equals to A. Then if that is the case, then we'll let our second angle, which is be our reference angle. Now let us look at our equation that we are required to solve here. We need to find the general solution of this equation. We are given cos theta equals to minus cos 2 theta. I said to you, this negative here is just telling us that we are supposed to be looking at the quadrants where cos is negative. Which are those quadrants where cos is negative? Cos is negative in 2 quadrants. It's negative on the second quadrant. It's also negative on the third quadrant. So that's why we are going to be using 180 minus an angle and 180 plus an angle, plus a reference angle. So I said, since we have cos theta equals to cos 2 theta, then we let 2 theta, which is our angle B 2 theta, to be, we use it as a reference angle. We use this 2 theta as a reference angle. So we are going to be using the first one there, which is angle equals to, which is our theta, equals to the reference angle, 180 minus our reference angle, 180 minus 2 theta, plus K times 360, where K is an element of all integers. So by looking at our equation now, you can then move this 2 theta to the other side because we want to solve for theta. 2 theta plus theta will then be 3 theta because this 2 theta, when it's moved to the left-hand side, it will change its sign. And then we are left with 180 degrees plus K times 360, where K is an element of all integers. Then, because we want theta, we are going to divide by 3. We are going to divide by 3. And then when you divide by 3, you will be left with theta equals to 180 divided by 3, which will be 60, plus k times 360 divided by 3, it will be 120, where k is an element of all integers. So these are going to be your general solutions. Or in fact, it's the general solution for the second quadrant, and then we must also do for the third quadrant, because of course that's where cos is negative. So it was indicated that cos is going to be negative, so we use the third quadrant as well. In the third quadrant, it's 180 plus our reference angle. We said our reference angle is going to be 2 theta. So theta is equal to 180 minus 180 plus 2 theta plus k times 360, where k is an element of all integers. And then theta is equal to minus theta, because when you move this 2 theta to the other side, it's going to be negative 2 theta plus theta, which will give us negative theta, equals to 180 degrees plus k times 360, where k is an element of all integers. And then we are going to divide it by negative. It will be negative theta equals to 180 minus 180 minus, because we divide by negative, or we are going to divide by negative. We are going to divide by negative. So it will be 180 plus k times 360. Then we are going to divide by -1 to make our theta positive. So we are going to divide everything by -1. Then our answer is going to be theta equals to minus 180 minus k times 360 degrees. So that is going to be our general solution, our second solution. And then we also have this one here. I hope we are still following. Now moving to the next one, which uses cofunctions. As I said, you need to check whether is it possible to use cofunctions. If you can try to recall the previous example that we've just done, you can see that here you have different ratios. We have sine, you also have cos, but using cofunctions or using co-ratios, you will be able to make these two the same. Remember that sine 90 minus 2x is the same as cos 2x. Again, sine cos, maybe let me say cos 90 minus x is the same as sine x. So you need to change here your cofunctions, make sure that they look the same so that you will equate the angles, because for now you can't do anything with the angles because we are dealing with two different things. We have sine, you also have cos. So we can change this cos 2 theta and write it to be exactly the same as sine. So it's going to be sine 90 minus 2 theta. It's going to be sine 90 degrees minus 2 theta. So now you can see that we are dealing with sine. So using cofunctions to make trigonometric ratios the same, they are now the same. We are using cofunctions, then now our trig ratios are the same. So once they are the same, then you can now equate these two, because now for these two to be true, or for this side, the left-hand side, to be equal to the right-hand side, then it means this angle must be equal to that angle. Then we are going to use our B as the reference angle, which is 90 minus 2 theta. Then this is going to be our reference angle. And then because sine is positive in the first quadrant, then we are going to drop down our angle x minus 20 equals to 90 minus 2 theta plus k times 360, where k is an element of all integers. So that is for the first quadrant. And then we are also going to now, why am I using theta and x? I think there is, let us use theta. It's supposed to be the exact same angle. So this should be theta, not x. It's supposed to be theta. Yes, so I have theta minus 20 here. It's supposed to be theta. Then if you transpose this 2 theta plus theta, it's going to give us 3 theta. Then we transpose negative 20 to this side, then we are going to have 110. 90 plus 20, it's going to be 110 plus k times 360, where k is an element of all integers. Then we are going to divide by 3 because we are looking for theta. Then divide by 3, divide by 3, divide by 3. Then we are going to say 110 divided by 3, which will give us 36.67. And then if it gives us 36.67, then this one should give us 120k, where k is an element of all integers. So that would be our first solution. And then now we want to do the second solution. How are we going to do the second solution? The general solution, we'll look at sign. Sign is also positive in the second quadrant. So in the second quadrant, we know that in the second quadrant, it's theta equals to 180 minus the reference angle plus k times 360, where k is an element of all integers. So theta equals to 180. What is our reference angle? Our reference angle is minus 90 minus 2 theta. Minus 90 minus 2 theta plus k times 360, where k is an element of all integers. Then theta is equals to 180 degrees, negative times 90, it's negative 90, negative times negative 2 theta, it's plus 2 theta plus k times 360, where k is an element of all integers. And then when we take this 2 theta to the other side, it's going to be minus theta, because negative 2 theta plus theta will give us negative theta. Then 180 minus 90 will give us 90, equals to 90 plus k times 360, where k is an element of all integers. So yeah, that should be our solution. We then have to divide by negative. We divide by, I think for the second solution, I've left out to 20, sorry. 20, we should be having 20. It's not only theta. It's supposed to be 20. It's supposed here, our angle was not theta. Our angle here was x minus 20. So it's theta minus 20, theta minus 20, theta minus 20. So we should be adding theta minus 20. Then we should be adding this 20. This side, this will give us 110. It will be giving us 110, 90 plus 20. Then theta minus 2 theta will give us negative theta equals to 110. It should be 110 here. So it's going to be negative theta equals to 110. So it's 90 plus 20 plus k minus 3 times 360, yes, where k is an element of all integers. Then we are going to divide by negative, then it's going to be theta equals to minus 110 plus k times 360, where k is an element of all integers. So that should be our solution. Then moving to the next one, which is the same as the other one. We are using trigonometric ratios. Let us look at this one. We are still using trigonometric ratios. For the trig ratios, we said using these co-functions, then we must be able to write them as the same thing. So if we have sine and on the other side we have cos, then we must change. So we can change this sine and write it as a cos. So when you write it as a cos, it will be cos 90 minus 2 theta equals to cos into theta minus 50 degrees. And then by looking at these two now, you can see that the ratios are the same now. Once the ratios are the same, then we know our angles then should be equal. Then we take theta minus 50 degrees as our reference angle. Then because cos is positive, we are going to use the first quadrant solution, which is reference angle plus k times 360, where k is an element of all integers. And then our first angle, it's 90 minus, it should be 90 minus 20, 90 minus 2 theta, sorry, not 20, it's 2 theta, equals to our reference angle, which is theta minus 50 plus k times 360, where k is an element of all integers. And then you need to solve by taking this theta to the other side, and then we move 90 to the other side. Then it's going to be negative 3 theta. Negative 3 theta equals to 90 and also 50. 90 when moved to the other side will be negative, and then it's going to be negative 140 plus k times 360, where k is an element of all integers. Then we need to divide by 3, by negative 3, so that we get theta. Then when we divide by negative 3 here, we get theta. Divide by negative 3, divide by negative 3. And then 140 divided by negative 3 should give us 46.67. 46.67. Then when you divide by 3 here, it will be negative 120k, where k is an element of all integers. So that's how you deal with this type of equations. I hope we have learned a lot today. We've tried to cover the trigonometric identities. We've also covered trigonometric expressions using reduction formulas, using co-ratios. We've also covered the general solutions. So allow us then to say it has been a pleasure having you today. We'll meet again next week. Thank you very much for your time. Have a very good evening. Thank you.